and had some example. So before we move on to the next topic, I have this question for you. So we will quickly check if we can show that A bar BC plus A B bar C bar plus this. The whole equation is equal to B bar into A plus C bar plus BC, right? So once you are able to do this, it will be a quick revision of what we have done in the last class. Can you all try? Just try. A bar BC plus A B bar C bar plus A bar B bar C bar plus A B bar C plus ABC is equal to this. Since we have a long term in this side, we will begin with the LHS and we will show whether that is equal to this RHS, right? So please everyone take pen, paper and start to work out. So it will be a quick revision of what we did in the last week. So it begins like A bar B C plus A B bar C bar plus A bar B bar C bar plus A B bar C plus ABC, right? So this is the equation I have on the LHS side. So this is going to be my LHS. My LHS is equal to A bar BC plus A B bar C. Make sure you're copying the correct answer, right? Because I mean, correct question. Before you start, please double check. A bar BC, A B bar C bar, A bar B bar C bar, A B bar C plus ABC. Please double check so you don't need to waste time. Okay, fine. So now, before we begin, we just try to check whether there is any common things, right? So before we proceed, we can check whether there is any common things. So maybe the same thing is repeated again, right? There is nothing like that. So starting from, okay. So we see some common values, not the common expression, but we have some common values. Like there are B here, B here. We have A bar here, A bar here. And we could see in the final equation also is along. Yeah, what's that? So we will just organize how we can simplify them, right? So we shall just try with the first one maybe. So we have A bar BC, whichever which is closer to this could be maybe this one. I'm just trying. I don't know. A bar BC plus A B bar C. I'm just reordering because according to the law, even the reordering doesn't make any changes. And we have A B bar C bar plus A bar B bar C bar plus ABC is still there, I think. So I'm just reordering the stuffs. So we can just have a look and see. Right. Now we see, okay, let this be a side. Maybe in this one you can see B bar C bar is common and we have A. And in this scenario, you have A only, C is common. So I will take C here. Maybe I'm just trying, okay? And if I take C, we have A bar B plus we have A B bar. I think it doesn't make any sense, but okay, let it be. So if you take here, you have common factor B bar, which is with A plus A bar. C bar also common. And we have this ABC as it is. I think we have to pair up with this one only. Okay, we will see. Now, I think here there is no point, so I don't need to do it. Maybe I will leave it as it is. AB bar should be C, right? So what would be the output of this one? What would be the output of this one?
B bar, C bar.
B bar, C bar. Why? Because we can give a reason here. What's the reason? A
A
plus
plus A
A
bar
bar
equal
is
1.
equal to 1. So with that verification, we are going to do A bar B C plus A B bar C. Even I'm bringing the other factor also this side. And now we have something like B bar C bar. Only that we have. Now we have to again look for any possibility, right? So B bar C bar is there. So we will check for any possibility from here. You can see in this one, the first expression and the third expression. Does it have any common factor? Just check that.
B,
Yes.
C.
C is common. Yes.
C.
So we will come up with B C, sorry, B C A bar plus here we have A, right? So A here, then we have our other, this one. This is not yet paired with anything. So I'm just leaving it as it is. And we have this B bar, C bar. Okay. Now, what happened? Again, we use the same rules. A plus A bar is equal to 1. We are left with BC
BC plus
plus
AB bar C.
A B bar C plus B bar C bar. Right. So you can see something, right? From this, whatever the one we need in the RHS, we have found this person. Can you see? This BC has already come now, right? So what you can do again is BC you have,
B
and
bar
some
is
should be
B
common.
bar.
Yeah, B bar is common. And which is paired up with
AC plus
AC
C bar
plus
plus C bar.
C bar. Okay. Are we done? Are we done? Are we done with this? Still, we have not received anything closer to this one. I mean, if it is your normal one, maybe if you leave here, it's okay. But still, we have a problem. We didn't have the one which is similar to this RHS. We have this BC, no problem. So something else we have to do. B bar is also there. So what is here? AC plus C bar. What is this form?
X plus XY.
X plus? X plus?
X bar by.
X bar Y, which is equal to
X
X
plus Y.
Y. Now, in our case, X is C bar. Do you agree with me? X is not
Yes.
C. X is my C bar and my X bar is C. Now tell me, instead of this one, what do we write? X and Y. What is my X?
A
C bar.
C bar.
What is my Y? A.
A.
I think we are right. But anyhow, since the RHS is in a different format, I'm just going to rewrite them. B bar into A plus C bar. Now this becomes a complete answer. Right? Right? It's visible, right? So this becomes your complete answer. You begin with the LHS and you go step by step and you have showed the equation and everything. Now you have like this. Okay. So I think it is a quick revision. Hope you remember what we learned in the last class. Am I correct? Can I proceed? So we are moving on to the next one. Is that okay with everyone? Anyone has any doubt? Any doubts or shall I continue? Anybody?
Continue, miss.
Okay, so I believe that there is no doubt. So let me continue. Let me clear all these annotations. Right? I will just continue from here. And this is another way where we are using some sort of Boolean algebraic laws. So last class we saw something like simplifying only. And there is something like show that LHS is RHS. LHS is equal to RHS. There is also some kind of a question like this, finding the complement of the expression. So if you take, generally, if you have X, what is the complement of X? What is the complement of X?
X bar.
Bar, right? So likewise, they might be asking you to find the complement of any expression. So in this case, you can't simply write X plus YZ. The complement is equal to X bar plus Y bar. What is it? Y, you have Z, and you have a bar, you have a bar. This is not a complement of this. Rather, for the whole expression, you have to negate it. So simply what I would say is, if someone asks you to find the negation of X plus YZ, you have to find the bar of everything. For the whole thing, you have to find the negation, which is called as a complement. So for finding this one, we already learned one law. Can anybody recall? What is the law we can use to find the negation of an expression? We learned like 21 laws, right? What could be used here? Can anyone help me?
X bar.
No, the last rule. What is the name? I will scroll back to the slide. And what is this rule? De Morgan's theorem. This De Morgan theorem can be used to find the complement of any equation. So just by looking at here, you can see if X plus Y whole thing bar, what we do is we take separately a bar for this value and a bar for this value, and it is multiplied. Now, the same thing if you are applying here, it is going to be, what's that?
X bar
into
YZ bar.
YZ
Bar.
is for the whole thing. Okay, it is for the whole thing, but we can't leave as it is because again, we have Y into Z whole thing bar, which follows this one. What happened here? If you have a multiplication in between and a whole thing negation, what is the output? XY bar, XY whole thing bar is equal to X bar plus Y bar. So now into, what is YZ whole thing bar? Y bar plus
Y bar plus XZ bar.
Z bar. So now this is the right. So now this is how you find the complement of any equation. So if you want to find the complement of the expression, generally you make use of the rule De Morgan's theorem, which summarizes X plus Y whole thing bar is equal to X bar into Y bar. Or if the other way, if it is a multiplication, XY whole thing bar, it is equal to X bar plus Y bar. So this is the ultimate use of this De Morgan's theorem, generally to find out the, what is that, the complement of any expression. So I think you can just have a look at the next equation also. Or just try A bar B plus C D bar. How will it work? Let me clear all the other annotations. You can have a look. So for the whole expression, we have to get the negation. So it is going to turn out like A bar B plus C D bar. For the whole thing, you have to find the negation, right? So if you think this one as X and this one as Y, what is the form this follows? Addition or multiplication? It is look like an addition, right? X plus Y whole thing bar. So what is our complement going to be?
Multiplication.
Multiplication. Multiplication how? X bar into Y bar. So I have A bar B whole thing bar. Is that correct?
Yes, in multiplication.
Into what? My
C.
Y. My Y is CD bar into
Whole
bar.
bar.
So see, this addition will become a multiplication, right? So my x is a bar b, so my x is here. My y is cd bar, my y is here. Now it is in the form of x bar into y bar. But we can't leave as it is since we have some more equations here. So you can see again, this is in the form of what? xy halting bar, which is going to result in an addition. Am I correct? So this is going to be x, y halting bar. What is x, y halting bar? X bar plus y bar. So it is going to be a bar plus
B bar.
bar. Again, it is multiplied by c bar plus d bar bar. Okay. Now, what is double complement of a bar bar? What is double complement? A plus
B bar.
b bar. It is multiplied by c bar
Plus D.
plus
D.
okay. That's all. That's the equation. Either you can just remove the brackets and write, but this is totally fine. You're just taking this one. No need to distribute and write. This is enough. So maybe some couldn't follow up with me. I'm doing it again. You can have a look. See, if you take this, this is in the form of x plus y. Your task is to find the complement of them. So where you're going to find the complement of them. So if you want to find the complement, if there is an addition in the middle, I told you it is going to turn up as a kind of a multiplication. So this x will be x bar should be written here. Y bar should be written here. That is the fact. Okay. Now x is equal to a bar b. So you can simply look at here. Our x is equal to a bar b. So it is going to be a bar b. And since we need a negation, we write it like a bar b halting bar. Again, instead of y, we have to replace with cd bar and whole negation. So it's going to be cd bar bar. Now, again, we are not left with a single part. Rather, another time we have an expression which is a bar into b. This is in the form of what? X, y, halting bar. So we write it like x bar plus y bar. So that is how we have written. And since already there is a bar for a and we use another complement, it becomes a double bar, which is finally arising as a, right? So this is how we find the complement of any expression, making use of the Boolean algebraic laws, right? So this is how we work, right? With that, we move on to the other one, right? So as we see, most of the expression we encountered these days follow a kind of a format, I would say. That format actually is called as sum of products. So what do you mean by sum of products? Mean A into B, A into B bar, A bar into B. They are all called as a product. Why? It is multiplied. Right? They all are multiplied. You can see A into B bar, whatever, it is multiplied. So whatever which is multiplied, generally if you write X into Y, this is called as a product. If it is written as X plus Y, we call it as a sum. Right? So maybe if you take 4 into 3, 12 is the product of X and Y. Again, if you take 4 and 3, 7 is the sum of X and Y. So if you are okay with that term, you can have a look at here. See, these kind of expression, the way of writing this expression is called as sum of products. Because why? We have products AB bar, A bar B, all are added. So it is the sum of the products. We have the products here and it is the sum. It is SOP. Generally, we write it as SOP, SOP form, which is called as sum of product. And again, it is going to be the other way if we write. So you can see within the brackets, if we have the sum, and if they are multiplied by one another, they are called as product of sum. Right? Have a look. Have a look. How is it there? So sum of products means, see, they are product and it is added. That is why it is called as sum of product. Max term, product of sums mean, see, it is multiplied, the sum are multiplied. That is called as product of sum. And the other term we use for this is called as min term and max term, which I can show you from the next slide. Right? So why these are called as min term and max term is mainly because of the word called as fundamental product, right? So fundamental product mean generally if there is a product mean A and B multiplied, okay? If there is a product which can produce a high output, they are called as fundamental products. So as you can see here, right? If A is equal to 0, follow up with me. If A is equal to 0 and B is equal to 0, right? To have 1, output Z is equal to 1, what should we multiply? Just think that way. Always, if you want to have the fundamental product as 1, right? But the variables can vary, A0, B0, likewise, this can vary, Now, to always have this output 1, right? At this moment, to have an output as 1, this is A, B. A is 0, B is 0. What should be multiplied to get 1? A bar and B bar. Why? If A is 0, what is A bar?
1.
1. If B is 0, what is B bar?
1.
Then it becomes 1 into 1 is equal to 1. Now apply the same logic here. If A is 0 and B is 1, what should we multiply to get 1? A bar and B. This becomes 1. Likewise here, A is already 1, but B is 0. So we have to negate it. A, B bar is equal to 1. So this is how we define the fundamental product. So now you see, if you go back to this one, whatever we have here, if you want to get the fundamental product as 1, right, we have to follow certain things. Now we will see how does it work, right? Now see, if A is 0, B is 0, C 0, to have a 1 as a product, what should we do? What should we do?
A is a bar, so 0.
Since all are 0, we have to, what we have to do? Everything should be negative to get 1, right? That is A bar, B bar, C bar. Now do the same thing for all the 8 things and see. Just take this line. If you want to get the product as 1, what should we do? Take this 1, 0, 1.
B should be the opposite.
So it's going to be what? A, B bar, C. So why I'm taking much time is, in the future we have to, I ask you to design some circuit and you have to derive the equation from the truth table. So for that, you should have a clear idea, what is it, right? So if it is 0, 1, 0 mean, if your truth table is like 0, 1, 0, you must be able to write A bar, B, C bar or something like that. Okay. Now, this is our sum of product form. At the same time, Earlier, what we discussed was this one. Just a moment. Right. So, sorry for that. I had a small thing which I have to respond. Right. So you can see A, B, C. It follows if it is a fundamental product, we have to get a high output as 1. But if we are doing the other way, which is called as the product of sums, right? In that case, we have to have our variables. I mean, the variables in a form where the sum should be 0, right? Now, to have this sum should be 0, right? Always should be 0 mean. And when the variable is a, b, c is equal to 0, 0, 0, what should we add? Simply a plus b plus c. And again, if you take this line, just take this line. If you take this line, if we simply add a plus b plus c, what is going to be our output? A plus b plus c, what is going to be our output?
1.
1.
But we need to have 0. To have 0, we have to make this 1 and this 1 to be 0. For that, what should we add? Just follow up with me. A plus
B bar plus
bar.
C.
B bar plus C bar.
So this is how you decide how the variable should act, right? If you are following the sum of product form, generally you have to make sure if A is 0, right? Right? If A is 0, A bar will be 1, something like that. And on the other hand, if you have the product of sum, in that case, you have to make sure that the sum is 0. If it is A plus B plus C, we take it like 0 as it is, right? So this is how we derive the equations for sum of product and the product of sum. Maybe some of them couldn't follow up with me. When we do some examples, you can definitely understand. But again, even I want to just do it again. See, most of the time we don't follow this format. We prefer this format. This format, right? So whenever you are following this format, what we can do is here. You have to check here, right? So in this instance, if A, B, C, if they are added, A into B into C, it is going to be generally 0. But we want the product to be 1, which means this should be made to 1, this should be made to 1, and this should be made to 1. So to make this to 1, we multiply A bar, B bar, and C. That is the logic. And if you take here, we already have 1 and 1. And if you are multiplying with this 0, it is again going to be 0. So we have to make this as 1. So how should you multiply that? A into B bar
B bar into C.
into C. So this is how you derive the expression. Okay. So now with this, we move on to the next part. Right. So this is how we say, if it is a sum of products mean, generally for each row of this truth table, the output should be 1. We have to get it likewise. And if it is the product of sum, the output should be 0. That's it. And most of the time, although there are two ways of writing them, the way of writing, we always prefer this format, minter, right? Fine. So now, if some instances are given and you are given a truth table like this, you will be asked to derive the equations from here. So just imagine this is a truth table of what is that? A logic circuit, right? Truth table of a logic circuit, just think. So now they have given you, this is how the system is working. So from this truth table, you have to derive the equations, right? You have to derive the equations from here. Now we will see, just follow up this, forget the product of sum form. We have to just focus on the values where we have 1 and omit this 0. That is the rule, okay? Now, just if you have a pen and a paper, can you please copy this truth table? Quickly copy this truth table. A, B, C with 8 variables, and you have 0, 1, 1, 0, 1, 0, 1, 0. This is, I would say, this is somehow a system is working and it is given through a truth table. When we do the next part, you will understand how this truth table comes. Have you copied?
Yes, miss.
Yeah. So now, when you want to derive the equation for your Boolean expression from this, what you have to note is the values at these places, right? So, can anyone find out if A0, B0, and C1, to get this one, what should be the values here?
A bar,
A bar,
B bar,
B bar,
B bar, C.
E.
Now, do the same thing here. A bar,
A bar, B, C bar.
good. Here,
A,
okay,
B bar, C bar.
ABC bar.
C bar. And here,
A, B, C bar. A, B, C bar.
now see, we have found out what are the places we have the maximum output 1. Now our just task is to write it as a sum of product. Now we have the product, what we write is as a sum. That is how we derive the equations from a truth table. B, C bar plus A, B bar, C bar plus A, B, C bar. Now, this is, if you want to write it as a sum of product equation, we just try to find the values wherever we have a high value 1 and we write it as a sum of product. And on the other way, if you're going to utilize the product of some form, or if the question is to ask the product of some form, right? So what we need to check, 1 or 0? 1 or 0?
0. Production of sum, 0.
Yeah, if it is for the product of sum, you have to check 0. So for this 0 mean, you are going to focus on this one, this one, this one, and this one. Now we will find out every places. So for this one, A0, B0, C0 mean, to have this 0, what it should be? A
Plus
plus
B.
B plus
C.
C. That's all. Here it is going to be A
A, B bar,
plus
B bar,
bar,
plus
C bar,
make
C
sure you
bar,
insert a plus. Okay, C
bar,
bar. Okay. And here it is going to be A bar,
A bar,
A
B,
bar
C bar,
plus B
B, C bar,
C bar,
bar. And here it is going to be A bar with A bar
B bar,
B bar,
C bar.
plus C bar. Now, if you are asked to write your equation as a product of sum, what you want to do is gather all these values and write it as a product. You have the sums with you. You're going to write it as a product. A plus B plus C, right? Which is multiplied by A plus B bar plus C bar. And again multiplied by A bar plus B plus C bar plus A bar, B bar plus C. I think I missed a plus.
Excuse me, miss.
What's that?
Excuse me, miss. So for an example, you tell like we have to get the output for 0, A plus B plus C. For the instead of A plus B plus C, if we get A plus B bar plus C bar also
I didn't get your question. What is your question? Are you there?
என்ன சொன்னா மிஸ் அந்த ப்ரொடக்ட்ஸ் ஆஃப் சம்முக்கு வந்து நம்மளோட அவுட்புட் அந்த 3 டிஜிட்ஸ் இத ஆட் பண்ற அவுட்புட் வந்து 0 வரணும் அப்படியா?
ஓ 0 வரணும். இப்போ நீங்க இங்க 0 வரணும்னு சொன்னா 1 1 1 தானே இருக்குது. மூண்டையும் கூட்டினா 1 தான் வர போகுது. ஆனா எனக்கு 0 வரணும். அப்ப என்ன செய்யணும்? 0 0 0 ஆகணும்.
ஓ ஆஹா அப்படியா? ஓகே.
Yeah. Others any doubt? But in the case of இது sum of product இருந்துச்சுன்னு சொன்னா அந்த பெருக்கி வாரது வந்துட்டு உண்டா இருக்கணும். அப்ப பெருக்குறதுன்னு சொன்னா அந்த 1 0 0 ஆல பெருக்க போகல it will be like 0 no. So you want to make this 1 and this also 1. That's why you put it like B bar and C bar. Others any doubt or is it fine? Can I continue?
Okay, miss, continue.
அப்ப மிஸ் என்ன சொன்னா இப்ப ப்ரொடக்ட்ஸ் ஆஃப் சம்ல ஒரு ஈக்குவேஷன் வருதுன்னு சொன்னா அது இவென்ச்சுவலான வேல்யூ இப்போ y வந்து 0 தானே அது எப்பவும் ஆல்வேஸ்
0 இருக்கிற மாதிரி தான் எடுத்து நம்ம அந்த சம்ம செய்யறது தான் அது. லைக் என்ன சொல்ற நீங்க உங்களுக்கு தார ஈக்குவேஷன்ஸை வச்சு நீங்க ஃபர்ஸ்ட் ட்ரூத் டேபிள் செய்வீங்க. இந்த என்ன சொல்ற அந்த ஃபண்டமெண்டல் ப்ராடக்ட் டிரைவ் பண்றதுக்காக தான் நம்ம அந்த 0 உங்க அந்த டேர்மை யூஸ் பண்றது.
உங்களுக்கு அந்த லாஸ்டா ஒரு மெயில் பண்ண அந்த क्वेश्चन வந்து இதே ஈக்குவேஷன் ப்ராடக்ட்ஸ் ஆஃப் சம்ல தான் தந்திருக்கு. ஆனா அந்த ஈக்குவேஷன் 0 தான் நீங்க வருதுன்னு சொன்னீங்க.
இல்ல இது உள்ளுக்குமே இங்க ப்ராடக்ட் ஆஃப் சம் இல்ல. உள்ளுக்கு சம்மே இல்ல. நீங்க அனுப்பினது ப்ராடக்ட் ஆஃப் ப்ராடக்ட்.
ப்ராடக்ட் ஆஃப் ப்ராடக்ட் இல்ல.
Yeah, just check it. I
Yeah,
think
okay.
it's 2018 or something. And for your information, I'm not the paper setter. Okay.
Okay, okay.
I was on my study leave during that time. Okay. So here, see, this is how. Product of product means how is it going to be? Like when it is multiplied, it is going to be 0, no? The one you sent me. But here, there is a chance when you are getting 1 also. Why? Because you have a plus in the middle and we can always guarantee the other values are not working. Okay. So don't confuse both. That is product of product. Don't that maybe I think that's a typing mistake and maybe they have corrected during the exam hall or something. I don't know. Okay.
Okay.
So here, whenever you are given a truth table, just take care of zeros when you are asking the product of sum, or if you're asking a sum of product, please only focus on one, right? If you want, you can just take a screenshot or something. We can move to the next part. right? So to move on, I think you have taken. So we'll move on to the next one. Right. So simply, we are coming step by step, right? I taught you how to write the Boolean expression and how to get the expression from the truth table. And now we will see how we define some logic circuits and how do we do the logic diagrams. You can see when we have this kind of equation, you will be directly able to write no. So how to get this truth table is the question, right? So now you see, maybe here. See, first we will start this. After that, I will give you some case study like questions, and after that came up, and that's the topic for today. So now,
Miss Bingrude,
huh?
Miss Bingrude, most significant.
Are you talking to me? Who's that?
Hello.
Yes. Number 59. Are you talking to me? Number 59. Are you talking to me? Okay. Now see, we will first see this example. You are given a logic diagram for this, right? For this particular equation, you have to draw the logic diagram. After that, minimize the expression. After that, draw the logic diagram. So in the first class itself, I told you why we need to simplify the equation is because mainly if you have a large circuit, the propagation delay, the gate, and even the cost of implementing that is high. So to avoid that, what people does is, right, they try to minimize the expression as much as possible, and they try to implement the circuit only for the reduced expression. So if you can have a look here, if you want to implement the circuit for this one, A, B, C, and all, you need more number of AND gates and OR gates and NOT gates also. But if the same expression could be reduced and we have A into B plus C bar mean with a single NOT and OR gate, you can implement this, right? Right? So that is why we try to minimize the expression and draw the circuit for this one, right? And I have some more questions here. When I upload the slide, you can try. So we will move on to the this one first. After that, come to the Cayman. I have a condition here. We will see how to design a circuit in this case. Can you read this? Can you read this? Is it visible? Example number 4.
Yes,
Example
miss.
number 4. Okay, we have
Yes.
a question here. Example 5, 6 also there. No, okay, we will start with the example 4. After that, I will teach you K-map. I don't want to trouble everything together. So we will come up with this. So here, a traffic light control system. See, this is how a question will come. A traffic light control system needs to be designed for a side road which allows the cars to pass, read it very carefully, when there is no traffic on the main road. Only if there is no traffic on the main road, a car can move, which means the output signal or the red light or the green light will blink as green. If there is a traffic on the main road, which is m is equal to 1, they are telling you, if there is no traffic, we write it m is equal to 0. If there is yes traffic, we write it m is equal to 1. They are called Boolean condition. Cars can still pass if a pedestrian is not present. Now, you have to design a circuit which takes M, the main road traffic, and the pedestrian request, if there is present or not, you have to check. And you should have an output side road green light S, right? So you can see, wait, I'll just copy this to an Excel sheet and that will be easier, I think. Wait a minute. Let me open up a new sheet for you and is my question. Okay, my question is here. I'll just try to take a screenshot. Wait. Okay, so let me open up. I think I have to open it parallelly. Screenshot doesn't work. Just a moment. Yeah? Okay, I will minimize this. I will share the whole entire screen. Do you see my Excel sheet? Do you see my Excel sheet now?
Yes,
Yes,
miss.
Yes.
Yeah, I will open Acrobat also parallelly. Okay, now you have both parallelly. Please have a look. Now, based on this, I give you time, right? So please concentrate well. Please concentrate well and see how many variables are involved. How many input variables are there? How many output variables are there? Please take time and read carefully and tell me how many input variable and how many output variable are there. Huh? They're talking about two things. First, you have to check the traffic on the main road and you have to check the availability of the pedestrian. Both are Boolean variables with only 0 and 1. According to these two variables, the traffic side road green light should blink or not. MPS, these three are there, right? So, how many variables? I already put, you can just have a look and see. What is that?
So two input
Three.
and one output.
Variables.
Yes, these two are what?
Two inputs
Variable.
and one.
These two are input variable. And based on these two input variable, our output variable is going to work. Good. Now, if we have two variables, just see if we have two variable, how many possible values we can have? How many combinations we can have? Just tell me.
Four.
Four.
Only 4. Right. So what are they? 0,
One.
0,
Zero.
0,
0, 1, 1, 0,
0, and
1,
1, 1. Are you clear up to this?
Okay.
Okay, I think you can follow. Now, based on these two input, just a moment, let me put some columns also so that it is easy for you. So I will put borders and this is going to be my output, which is in different color, maybe light. Okay, now this is visible clearly, right? Now you are going to decide what is going to be your input, output, and all. Okay, fine. Now read the question again. A traffic light will work as it is if there is no traffic on the main road. What is the meaning? If there is no traffic on the main road, mean M is equal to 0. If there is no traffic on the main road, the green light will be on, which means the passengers can go. No problem. There is no traffic, so they can go. So, if M is equal to 0, if M is equal to 0, what is the output as S? The green light should blink. Whenever there is no traffic on the main road, which M is equal to 0, the light should blink. So what should be S? 1 or 0?
1.
All agree?
No, 0.
Pedest-
If there is no traffic on the main road, which is 0. If there is no traffic on the main road, the green light should be on, which means S is equal to 1. The side road has a green light. So what is S? 1 or 0?
Can we say without pedestrian crossway?
1.
And because they have given here, if there is no traffic on the main road, 1.
1.
And again, there is a rule here. There is no traffic on the main road means definitely the cars can pass. So what is this value again? 1. Whenever there is M is equal to 0, it is going to be 1.
Pedestrian 1. No.
Yeah, pedestrian is fine. But see the next condition. If there is traffic on the main road only, you have to check for the pedestrian. See, the question read it clearly. A traffic light control system will be designed for a side road which allow the car to pass, which means the S is equal to 1 when there is no traffic on the main road. When there is no traffic on the main road, straight away they can go. If there is traffic on the main road, what is the meaning? M is equal to 1. During that time, you have to check the car will pass only if there is no pedestrian, which means when M is equal to 1 and P is equal to what? 0. When M is equal to 1 and P is equal to 0, the traffic light will be, the green light will be on. In this condition, there is traffic on the main road and there is pedestrian also there. What you should do? Red light should blink.
0.
What is the value?
0.
0. Now, once you got this value, you can straight away write the Boolean equation for this. How to write? Tell me. If you are going to write it as a sum of product or product of sum, no problem. Now, for this question, maybe they ask you to write it as a product of sum. Sorry, sum of product. So you have to only focus on the values wherever you have 1. So what is the equation here?
M bar plus
M
P
bar.
bar
M bar.
plus P bar.
P
Is
bar.
it plus?
P
No.
bar.
Sum of product.
M bar.
P bar, not
P
plus.
bar plus.
M bar into
M
P bar.
P bar.
Plus.
That's all. That's all. Wait. Next line. M bar.
M bar.
M bar. P. P.
Next line.
M P bar.
M
P bar.
P bar.
Okay. Now what is the equation? You have to put a plus in the middle and write. What is that? M bar. P
M
bar.
bar plus plus
M
M
bar.
bar P plus
P plus
MP.
MP.
MP bar.
This is the equation. Now, if you get this equation, can you draw the circuit? It's easy. Am I correct?
Yes.
Why? You can just take it. Maybe you have two variables, M and P. So imagine this is your M variable and this is your P variable, right? So you have a OR gate, right? So before OR, you have some multiplication. So maybe you plug a NOT gate here and you plug a NOT gate here, which is going to be M bar and P bar. This is going to go to which gate?
And
AND gate. Good. So it's going to go to the AND gate. Now you have 1. Next, for the OR gate, for my main OR gate, it can have 3 things. 1 I received. What is my next one? M bar into P. So this is my P. And M bar, I think if I take the output after passing through the NOT gate, it is going to be P bar. Again, I have an N gate and it goes as in here. What is my third value? M
M
and P
P
bar.
bar.
So I think I have to take from here after passing through the NOT gate. These two are ANDed, which means multiplied. And this goes to the, and this is my output F or X or whatever. So if you implement this circuit, your traffic system is going to work. Is it clear? If you understand this, the whole logic of the, what is that? The whole logic is done.
Excuse me, Miss.
Yes.
Oh, and so now the not getting a mutton normal output, sorry, input one on the iricon, but and the minimum on the trend maximum and you can கொடுக்கலாம்.
அஞ்சு வரைக்கும் போகலாம் என்று சொன்னா அதுல இதுல இருக்கு. பட் நான் லாஸ்ட் கிளாஸே காட்டேன் தானே, ஹார்ட்வேர்ல ஒன்று தான் வரும், ரெண்டு இன்புட்டுக்கு ஒரு அவுட்புட் தான் வரும். பட் ஃபார் த ஈஸி drawing we even go up to 5.
என்னடா மினிமம் வந்து கட்டாயம் ரெண்டு இருக்கணும் தானே?
Yeah, that's true. At least there should be 2. Or else it will work.
Okay.
Right? So if you understand this, the whole Boolean logic is done. Is it okay?
Yes, miss. That's right.
Right. So now I'll give you another example. Right? Open up a new sheet. Right. In this one, can you try? I will also help you. Meanwhile, you also try. So actually, this is the overall thing why we need to learn this Boolean logic. Actually, to design this logic circuit from a specification given by a customer. If they ask you a security system or some kind of a system, you have to understand that, put that logic in a truth table, get it minimized, and you do. Earlier in our case, there were only 3 variables. I didn't go for minimization, but now we will see. Right, see here, read it carefully. A security system in a building is designed to allow access, A is equal to 1, only when certain conditions are met. So this is a security system. The system has 3 inputs. So I am going to have 3 inputs here, which is going to be S, K, and P. And my allow access A is equal to 1 means I have only one output. So this is my output. And these 3 are going to be my input. Okay, no? So far, is it understandable? Is it fine?
Yes, miss.
Now we just identified that we have 3 input variable and 1 output variable. So now tell me, if you have 3 input variable, how many combinations are possible?
8.
8. 2, 4, 6, 8. So the combinations are going to be 0, 0, 0,
0, 0, 1,
1,
0, 1,
0,
0.
0, 0, 1, 1. Similarly here, 1. Just copy this again. These are going to be 1. Just for, it is not a rule that you have to write only this order, but you won't miss anything if you write in this order. That is why it's a good practice to follow this. Okay. So a security system in building is designed to allow access. So A is equal to 1 when certain conditions are met, right? So we have S, K, and P. All these 3 are Boolean variable. S is 0 mean security mode is active. S is 0 mean security mode is not active. K is 1 mean there is a valid key card. If K is 0 mean there is no valid key card. pin entered correctly, 1 will, if it is a correct pin, P is equal to 1. If it is a wrong pin, it is 0. This is how the scenario is. Now, they are telling you the system will grant access where A is equal to 1 under only the following condition. If security mode is off, which means when S is equal to 0, access is granted regardless of K or P. What is the meaning? What is the meaning of this?
If S is 0 and others also could be the 0.
Others, it can be 0 or 1. They don't bother. Automatically, what happened?
Final output should be 0.
0 or 1.
No, it's opposite.
What do you mean? The system will grant access A is equal to 1 under the following condition. If the security mode is off, access is granted. Access is granted means A is equal to 1. Regardless of K or P mean, whenever the security mode is off, which means simply you have a locker, security mode is off. So why do you worry about the key card or PIN? No problem, no? Anybody can come and open. So it will be 1. Am I correct?
Yes.
Others? Others? Is it fine?
Yes, miss.
Simply they say the system should grant access, which means the A should be equal to 1 under the following condition, which means simply your security mode is off. No matter what, whatever the value for K or even the P, access will be granted. So when S is equal to 0, you don't need to worry about K or P, it is going to be 1.
All
Now,
open.
all are open. Now again, if the security mode is on, now they are telling you some condition. If the security mode is on me, this S is equal to 1. There are many thing combinations now. The K will be 0, input also 0. OK is 1 and this is it, something like that. Now they are telling you if security mode is on, this access is granted only if both a valid key card and a correct PIN is provided, which means the A will be equal to 1 only when K is equal to 1 and P is equal to 1. It's like a two-factor authentication, right? Even in Google, maybe they send an OTP to your phone, right? You have to click that. Then only it will verify and let you sign into your system. Even your transactions also, what they do, they send an OTP, you have to send it. Like a two-factor verification they are doing. When the security mode is on, you should have both K and P. Both should be on. So what is the output in these 4 conditions? This condition? A should
0,
be 0. This condition?
0, 0,
This one?
0,
This
0,
one?
1. Last one,
1.
only 1.
Last one only 1. Why? Because when the security mode is on, both should be on. Both should be on. Then only you will get an output. So from this, your next step is to derive the product of sum. So to derive the product of sum, what is this value? You have to focus on which values.
First one is 0.
Which one?
This one.
You mean this one?
Yes.
Security mode is off. So we don't need to worry about K and P. So it will be 1. Read this line. If a security mode is off.
They give the rules like this.
Yeah, they are telling the rules like this. If a security mode is off, when S is equal to 0, access is granted regardless of K or P. K can be anything, 0 or 1. Or P also can be 0 or 1. They don't care. Why? Security mode is off. So access is always granted. They are telling the condition. Based on this condition only, you have to take the truth table. Is it okay?
Can we do the SOP method also to this question, maybe?
No problem. But it's a product. SOP only you're going to do. You can do the product of sum also. Considering these 3 zeros.
For the patients, we can do whatever.
No purpose, no worry. But it is a good practice to go with the POS. Sorry, sum of product.
Sum of products. Okay.
Okay. So now, is it okay? The one who asked me, this should be 0. Did you understand?
Yes, yes.
Okay. Now, if you want to get the sum of products, first you have to get the products. To get the products, you have to find which one? The places where you have 1. So what is the product here?
S bar into K bar into P bar.
P bar. Here,
S bar into K bar
sorry, K bar, P.
P.
This one? S
S
bar,
bar
K.
K P bar.
P bar.
Here,
S bar
S
K P
bar KP.
K, P.
P.
Here.
S
S K P.
KP.
Now, if I want to put up the equation, you people have improved a lot from the first class to now. I don't know, like good improvement. You all are learning. S bar K P bar plus S bar KP plus SKP. Is that fine?
Yes.
Now, before going to the next step, to design a circuit for the above instance, you can see there are many variables here, right? But there may be chance that you can simplify them, right? So using Boolean equation, Boolean algebraic laws, you can try to minimize them. So we will now minimize them. So we'll just try, okay? So is there any common terms, I mean common expression repeating? No. But I think you can see S bar, if you take this one, these two, what's the
Yes.
problem?
KP.
KP is common.
Common.
Is it fine? Can you follow up? Okay.
S
Now
bar.
Huh?
S bar K bar is common.
S bar K. S bar K is common.
No. Front side. S bar
Here. You mean
bar.
here you are going to tell. Okay, fine. S bar K bar is common.
Common.
Do in one step. But for exam, please do step by step, okay? It will be good.
Can we shortlist to the S plus S bar to 1? Is that fine, or we have to circuit in the steps, man?
What is your question? You're going to write S bar.
No. S bar plus S, usually we can say 1.
Yeah.
So can we shortlist directly put it to KP?
Yeah, no problem. But if you show it with a method, it is good because you won't miss anything.
Oh, okay.
Yeah, even in the other instance, P bar plus
P.
P is equal to 1. If it is MCQ or something, no problem. But if it is a essay or structure, try to write step by step. At least if you miss something in the middle and your final answer is wrong, at least the steps can give you marks. Right? So what we are left with, I will write again. K bar plus S bar K plus KP. Something is missing. P. Right. So S bar K P bar, no? Right. Can we minimize again? Check.
S bar, we can get the comma. S bar
You
into
can
KP.
take command this side, or even you can take command this side. But anyhow,
S bar K bar.
S bar we will take command and write K bar plus KP. KP bar plus KP. So what is K bar plus KP bar? X plus XY format. Sorry, X plus X bar Y format.
It's a, if you take other method also, if you
But also
get
no problem. Anything is no problem. We'll first take this. I'll do both also. What is X plus X bar Y?
X plus Y.
So what is my X here? Check in these two. My X is K bar. Am I correct?
Yes, please.
And my Y is P bar.
K bar plus P bar. Yes.
Is it okay now? Is it okay? Even you can take the other side also. These two side also you can take. How? Taking K as common and S bar P bar plus P. Okay? Everything is fine. So can you check if you can reduce it further? It's going to be S bar, K bar, plus S bar, P bar, plus KP. Right? Can you reduce it further? I don't think there is a method, but it's okay now?
Yeah, it's fine.
Okay, fine. So now what you can do is simply you have S, K, P, right? And I'm going to plug in
Yes.
S. So even for K, I need a NOT gate. P also I need a NOT gate. Okay, for the time being, we'll just put. So now see, from S, bar comes, which is added with the K bar and P bar, right? So you have to first add these two. Add these two with the OR gate. And this value is what happened? Multiplied by S bar. For the first part, I have drawn something. Check, is it correct? K comes K bar, P comes P bar. Both are added, K bar plus P bar. And again, it is multiplied by S bar. So S comes, S bar is multiplied. This is the AND gate. Now we have this part is done. Is it okay?
Yes.
And now again, you're going to multiply K and P. So I'm taking from K and again,
P.
wait, okay. And I'm taking from P. What should I do?
And gate.
AND gate.
AND gate, multiply. Then both should be
OR
done
gate.
by OR gate. Good. This is the equation for my reduced expression. Now you have implemented a security system. So see, when you want to implement for this particular one, you will need more number of gates. It takes time. It's not only about the cost, even when you want to pass an input, and it takes some propagation delay also, like whenever the signal pass, it has to identify what is coming, and taking all this will take some time. So to make the system efficient and more affordable with less price, we always reduce and draw the logic circuit. So if I give a question like this, can you do? You have to find out the variables, find out the input, find out the output. Just do your truth table. Then with your truth table, what else you can do? Directly you get the... I have some personal messages I didn't check. I don't know. Yeah. So see, you can just find and you get it the product of sums or the sum of product, but it is a good practice to go with this. Okay, because why? Because as just by looking at S0, people try to put S bar. But if you are doing the other way, the other one, product of sum, you have to do the other way, but it is also quite fine. But people have a practice of using this. Okay, unless specified, put it in SOP or put it in POS, you can go with any method. Okay, is that clear?
Yes.
Yes.
So we'll take a very short break and we'll come back because we have only one more. Wait a minute. Right. So I leave this exercise to you. We have only one more small topic under this one, that is K-map. Right. So with this K-map, the logic part is over, and after that, hereafter theory only. The other logic, the computer organization part, right? So I mainly wanted to give more emphasis on this because this is important for further thing. That other parts you will anyhow learn in some other subjects also, but this is a basic and I want to give you a good foundation, right? So we'll take a short break. It's now 2:50. Maybe at 3 o'clock. Can we resume? Huh?
Okay, Miss. Okay.
Resume. Just take a short break. Just continuous talking. It hurts my throat. Okay.
Hello, madam. Hello.
Yes.
Hello.
Yes.
The time is the 3 o'clock. Wind up time. Winding up time.
What's that?
3 o'clock. Winding up time.
I started at 1:30, right? The lecture today is from 1:30 to 3:30. Why you have anything at 3 o'clock?
To go another time level.
Do you have any lectures at 3 o'clock?
Yeah.
What
We
lecture?
have to go. We have to go another.
Maths is
There is
there.
program. There's a program.
There is another program. How many people want to go?
I don't know whether I am saying that I should go.
You have to go. Is it okay if I continue? Can you get it from your friends or bring some doubts to the next class? Is it okay with you?
Okay. Thank you.
Okay, you can go.
Hello.
Yes. You want to go?
எத்தனை மணி வரை அடுத்து வரைக்கும் 3 o'clock இருந்து
3:30.
3
3:30. Why? Any problem?
3:30க்கு முடிப்பீங்களா?
Oh, in 5 வரை எடுக்கவா?
விளங்கல.
5 வரை எடுக்கவா?
இல்ல எத்தனை மணிக்கு முடிப்பீங்கன்னு கேக்குறேன்.
நான் 1:30 தானே ஸ்டார்ட் பண்ண. I will wind up at 3:30. Do you have to go?
Okay.
No. Is it okay?
Okay.
Yeah, when I put some messages in the group, if you have any problem, you can personally reply me, okay? In case you
Okay.
have some other things at 3 o'clock, most of you can't afford me, I'll somehow manage to start.
Okay.
Okay, today I had another program. It ended only around 1:15, so I couldn't come. That's the problem.
Okay.